Good morning, Salmat Pagi minions. Welcome, welcome. Good morning, guys. This is Shreyas here, your master teacher for physics, going live on a lovely morning, all for you to make you a hero from zero. So, welcome to the Zero to Hero series with me, Shreyas, your master teacher for physics. Hello, Nancy, Yalini. Hello Minion Aarti, hello Ankit Kumar, hello Divya Ranjan, hello. Good morning, nice to see all of you out here. And guys, if you are here and if you are new, do not forget the only way you can make friends, the only way I would know you are here, the only way you can interact with others is by, yes, typing it out on your chat box. So type out everything that you want to say, interact with every other person out here. So in the chat box, hello Shreyas Kapri, good morning. Nice to see all of you out here. And today we're going to have a lovely morning with circular motion. And guys, if you want to know more about me, you can definitely follow me on my Instagram handle, that's Shreyas_Vedantu. So I have been teaching for quite some time now, and I'm here on this JEE Enthuse YouTube channel so that all the people out there in the country and outside the country who want to learn and who want to prepare for all the competitive examinations in English, this is the channel for all of you. All right. So before we begin, do not forget to smash that like button down there so that you can show us all your support, and do not forget to hit the subscribe button in case you have woken up to this lovely morning and you have forgotten to subscribe to our channel for all the lovely videos that we come up for all of you. And this is the schedule, by the way, for Zero to Hero series. Hello Vikram Nirmal, good to see you back. Hello Amrita Raj, good morning. Hello Rajat Kulkarni, yes. Well Rajat, I woke up an hour back or so, maybe a little bit more. Yeah, and hello Gayatri. And if you were there in yesterday's session, you know why my hair and why I look like this. So it's going to take some while for me to get back to normal. I hope you know why. All right, so the Pathfinder series is starting tonight. So if you are a 11th to 12th moving student, we are starting the Pathfinder JEE 2022 series for all the 12th standard students. We are going to start with electrostatics and then move to Gauss law, and after every chapter we're going to have a quiz sorts of thing just to check how much have you understood and to make sure that you guys understand what are your weak points and what are your strengths. So that's the flow. So every Tuesday, Wednesday, Thursday at 9 o'clock, you're going to have the Pathfinder series for physics, and then the Zero to Hero series. Of course, we are here today, the circular motion, and then on Thursday, you're going to have it in optics and so on and so forth. So Zero to Hero series, all right, for all of you every day, so that you can prepare really well for the 2021 examinations. And if you are a 2022 aspirants, at least the 11th standard topics will be clear for all of you. And the 2021 students, also the Killer 5 series is going to start this Saturday for JEE advanced preparation. Topic wise, tough questions for all of you, 5 questions that will blow your mind starting this Saturday at 9 o'clock. So every Saturday for the time being, you're going to have the Killer 5 series. Hello Surya Deepan, good morning. Oh my god, my hair is too awesome, thank you, because I didn't comb it, I just put it back and that's it. All right, so can JEE 2023 also follow today's lecture? Well Nitish, you need a little bit of understanding of circular motion, the Newton's laws, kinematics part a bit. So if you are having some idea, Nitish Kumar, then on kinematics, Newton's laws and ekdam basics of circular motion, then definitely you can attend today's class. Hello Papi Reddy, long time no see. Yes, I will be taking all the chapters, Rajat, of class 11th, class 12th, everything. Hello Anish K. Okay, chalo, let's get going then. And guys, those of you who are from 11th and moving to 12th, remember the courses in Vedantu are starting very soon. There is a batch which is starting, I think, next week only. So guys, do not delay your decision, because in fact I have made a special video for 11th to 12th moving students on what should be the strategy and how you should prepare yourself for JEE 2022 and other competitive exams for the next 1 year. So just watch that video, it's there in the playlist, past videos, And remember, these long-term batches are starting. Some of them have started. It will prepare you for KVPY as well as board examinations and any other examination that you're writing, all under one cost. Also, you get doubts as well as which will be solved by all our doubt experts, as well as the hard copy of our Tattva material. All this at almost 1/3 the regular price of any coaching that you can talk about, at 43,739 rupees after a discount by using this coupon code SHHPRO. So do not forget to check out the link in the description box below so that you can avail this offer, join our pro subscription where even I am teaching in the micro courses and I'm also teaching in the 12th toppers batch. All right. So all other details and PDFs and updates will be posted on our Telegram channel. So do not forget to join our Telegram channel as soon as possible. Now to talk about circular motion, let's begin. Hello Aryan Dubey, good morning. Yes, hello Tejaswini, thank you for all the love from Pune. Nice to see you. Nice to see the Pune Repulton out here. Yes, there will be sure short 60 questions in April month as well. Amrita Raj, definitely. Good morning Karthik Reddy, good morning. Hello Tejaswini, good morning. Alright, let's begin our class. I hope you guys are all pumped up now. You can have your coffee, you can have your sandwich, you can have your breakfast simultaneously while you're watching this video. But do not forget to keep making notes using a notebook and a pen kept on the side. Hello Avinash, good morning. Now, remember, the basis or the easy way of learning circular motion is by comparing the variables, comparing the equations, and it goes like this. Displacement in linear motion is same as angular displacement, theta, in circular motion. Correct? Here it is meters, here it is radians. Velocity is similar to angular velocity. Final velocity will be similar to final angular velocity. Initial angular velocity will be similar to initial angular velocity. So velocity, angular velocity. Velocity, angular velocity. You can see that. And acceleration is similar to angular acceleration in circular motion. Then, if these terms are similar, obviously the kinematic equations are also similar. Like the final rate at which, what is the angular velocity? The final angular velocity is the initial angular velocity plus angular acceleration into time. Alright, very similar equations that you have already seen in 1D kinematics in translation motion. Similarly, instead of displacement, you have angular displacement is initial angular velocity into time, the initial rate of angular velocity into time plus half angular acceleration into time square. And last one, omega final square, the final angular velocity square is initial angular velocity square plus 2 times angular acceleration into the angular displacement. Now, to give you the proper definitions and all that, well, here it is. See, angular velocity is nothing but rate of change of angular displacement, and angular acceleration is rate of change of angular velocity. Remember what was velocity? Velocity was dx by dt. So here it is d theta by dt. And remember what was acceleration? It was rate of change of velocity. Here it is rate of change of angular velocity. And remember one more thing, you can also relate both of them in a very simple way. See, the length of an arc is r times of theta. The length of an arc, alright, is nothing but r times of theta. Now, you can write similar equations for everything else, like v, instead of length you put velocity, is r times of omega. Remember, length by time gives you velocity, theta by time gives you angular velocity. So very similar equations. And the tangential acceleration is r times of alpha. So velocity by time, acceleration, omega by time, angular acceleration. So these equations are very simple to remember. I hope this chart, this table, this screen over here makes things all the things put in a perspective. Alright, now if everything is clear, hello Rock Satvik. Alright, very good Anish. Alright, Yalini, good morning Avinash. Alright. Yes, Rajat Kulkarni, you can cover your backlogs of 11th with our 12th class. In fact, you should you should set aside maximum 2 days per week for your 11th standard portions, but your main focus should be 12th standard. But do not forget to simultaneously work on your 11th standard as well. All right, so let's get going with the next part. Now, having said that, remember one thing: any particle which is going in a circular path, all right, it has two kinds of acceleration. One is the tangential acceleration. This is the path, let's say, and the second one, it has nothing but the centripetal acceleration. The resultant of both of them is the total acceleration. So this acceleration is basically the centripetal plus the tangential acceleration together. Both of them together gives you the total acceleration. Remember, the value of centripetal acceleration is omega square r, or you can write it also as v square by r. Those are the formulas for centripetal acceleration. For tangential acceleration, it is nothing but just dv by dt, which is nothing but rate of change of speed. So if the speed is constant, doesn't matter what about the direction, if the speed is constant, then tangential acceleration is zero, because if speed doesn't change along the tangent, along the path, there is no acceleration. Understand? Centripetal is responsible for the change in the direction. So whenever the direction changes, there has to be centripetal acceleration to change that direction. So centripetal for direction, tangential for speed. Keep this in mind. Is this all clear? Ajay Saran, you're just probably 5 minutes late, but it's okay. This was the first slide topic wise. Before this was introduction and showing you the timetable for all the series like Killer 5 and Zero to Hero and Pathfinder. So you can just carry forward from here and watch whatever you missed later on. All right, so let's get going to the next one. Now, these are all the important formulas on one single slide. For example, centripetal force. All the forces acting towards the center together will be mv square by r. M into AC, you can see that because AC is v square by r. So mass into acceleration is the net force. That's it. Now, in a rotating frame, let's say guys, you are on a merry-go-round. When the merry-go-round rotates, is that frame where you are sitting an inertial frame or a non-inertial frame? Answer in the chat box. When you sit on a merry-go-round and that merry-go-round rotates, are you inertial or non-inertial frame? Come on minions, let me know in the chat box. Very good, Sujit. All right, come on guys, what do you think? Is it inertial or is it non-inertial? And if it is non-inertial, what do you need to account for? And if it is inertial, then are we clear for attempting the question just by applying the Newton's laws? Inertial or non-inertial? What do you think? Okay, very good. Ankit, no, it's not inertial. It is a non-inertial frame. Well, it is not an inertial frame. It's a non-inertial frame. Any rotating frame is a non-inertial frame because you will see the objects tend to fly outwards. There is kind of a mysterious force acting on all the objects which is trying to throw them out. That mysterious fake force is called as the pseudo force, but in case of circular motion, it is called as the centrifugal force. And the value of the centrifugal force, yes, is mv square by r or m omega square r. Understand, this force always acts outwards, away from the axis. Away from the axis, it is throwing out things. But remember, this force has to be applied only when you sit in a rotating frame, when you are observing things in a rotating frame. If you are outside and then looking at the things, then you will just feel that, okay, that body is accelerating, that's it, and you will write force is mass into acceleration. But if you shift that mass into acceleration on the other side, that MA is called as the pseudo force, centrifugal force. Understand that. So pseudo force is just a name given just to write or make those equations of Newton's laws. So as such, equation wise, it does not make a difference. It does not make a difference whether you're going to get a wrong answer or right answer. No, you will always get the correct answer no matter where you sit, as long as you apply these equations correctly. Okay, I hope this is clear. Now, these are some important values, like you throw a ball, a pendulum, and you want it to complete the entire vertical circle. So when you push it at the bottom, with a velocity of root 5 gl, L is the length, G is gravity, root 5 gl, if it's the velocity, then it will just be able to reach the top and it will come down like this. So as it goes up, its speed reduces, and at the topmost point, the speed must be root gl. If it is not root gl, then it will slack. So understand, if the speed is more than root 5 gl, it will be able to complete the circular motion. But if it is less than root 5 gl, let's say 4.8 gl, root of 4.8 gl or something like that, then it will go till here, it will become slack and it will fall down like that. So understand that. I hope that is clear. All right. Yes. Now, this is one thing. And remember, what is the velocity for a pendulum to just become horizontal like this and go till here? What is the velocity at the bottommost point for a pendulum to just reach here and go like this? What's the velocity, guys? Come on, answer in the chat box. Let's see how many of you remember that value. What's the velocity at the bottommost point for a pendulum to oscillate like this, like a semicircle? Come on. 0, max 0, max 0, max 0. Come on, what's the velocity? At maximum velocity or that velocity at the bottom point so that it goes like a semicircle. What is it? Root of how many GL? Come on, minions, do you remember it? Yalini says root 3 GL. Come on, think again. I don't think so. Think again. It's not root 3 GL, guys. No, yeah, 3. It's not root 3 GL. No, it is root of 2 GL. Keep this in mind. Not root 3 GL. That is wrong. Understand that. Root of 2 GL. Keep this in mind. You can do this using normal equations also. Half mv square is mgl. Half mv square is mgl. So if you cancel m and take the 2 on the other side, you will see the velocity is root of 2 GL. As simple as that. So root of 2 GL, if that's the velocity as it goes here, it will become 0, then root 2 GL, then 0, then root 2 GL, and then 0. So that's how it works. Okay, root of 2 GL. Alright, not root 3 GL. Root 3 GL is wrong. So in fact, if you remember the line root 3 GL, I'll tell you what that root 3 GL also is. If you throw a pendulum with root 5 GL, what did you do? You throw a pendulum at the bottommost point with root 5 GL. As it goes up, at the topmost point, the velocity will become root GL. Root GL. Over here, root 5 GL. When it is moving and then it just becomes horizontal, that time the speed is root 3 GL. I hope this is clear. So root 5 GL, root 3 GL, root GL, then root 3 GL, root 5 GL, root 3, root 3, root 5. That's how it works. I hope it is clear. But if you give it root 2 GL, then root 2 GL 0, root 2 GL 0, root 2 GL 0. That's how it works. I hope now it is clearly understood. Okay. Last thing, conical pendulum. So when you rotate a pendulum such that it traces the curved surface of a cone, it's called as a conical pendulum. All right. And some of you would have already experienced it if you have ever sat on a jhula or on a swing which is being hung by just a thread or a chain on the top, and you push yourself and you go like this and you go like this. So this motion is that of a conical pendulum. You go like this because the thread goes on the surface of a curved surface of a cone. All right. And you can use Newton's laws over there. Yeah, you can use Newton's laws over there, like tensions cos theta is mg. So there is tension, there is mg, there are the two forces, and it is going towards the center, accelerating towards the center like this, like this, like this as it moves. So tensions vertical component balances mg, and the tensions horizontal component or the sine component gives the acceleration. So it will be a mass into acceleration along the horizontal. So keep this in mind. Now, for banking related problems and for curved road related problems, remember, whenever a car goes on a curved track, all right, the acceleration towards the center, because the direction is changing. Who changes the direction? Is it mg? So Ajo Saran, Why is it root 2 GL? You can use energy equation, bacha. So kinetic energy converts into potential energy. Just write that equation. Half mv square is equal to mgl. You will see mm gets cancelled and velocity is root 2 GL. Yes. Okay. My God, Dinesh, where I have been? You are a ditcher. Where are you? Where were you? Why were you not present all this time, Dinesh? What happened? I hope you are finally awakened and finally you are going to attend all the classes now live. And yes, people are also welcoming you back. Good. But make sure that you do not miss all the classes now. All right. Now, whenever the direction changes, it is accelerating, remember? And what kind of acceleration? Centripetal acceleration. Now, will the centripetal acceleration be given by normal or gravity? Neither of them. Who gives that acceleration? Friction. Remember, without friction, or imagine if this road was smooth, the tires are smooth, how will the vehicle change the direction? It can never change the direction. You can turn the steering wheel, but the surfaces are smooth. It will never turn. It will just keep on going straight and you will bang onto someone. So the only reason why a car, a truck, a bike changes the direction is because of friction. So friction changes the direction. That means its mass into centripetal acceleration. Correct. Very good. Very good. All right. Thank you, Krishna Yadav, so much. Very good. Now that is when the road is flat. But, and by the way, you should know the formula. Root of mu rg is the maximum speed on a curved flat road. This is flat because it's given as unbanked. Unbanked means it's not turned. Oops, 1 second. All right. Okay, so it's flat, so it's root of mu rg. Then, whenever the road is tilted by an angle, if you tilt the road by an angle, then the formula changes. The maximum speed on a banked road, banked curved road is rg. Now you can divide the entire thing by cos theta. So if you want, you can get rid of this cos. You can get rid of this cos and you can write this sine, all right, as tan theta. You can write it as tan theta, and you can also get rid of this cos over here, and this will become 1 minus, and this will again become tan theta. So if you want, you can write it like this: rg tan theta plus mu upon 1 minus mu tan theta. Keep this in mind. Hello Jaideep, welcome. Okay, Dinesh, please give importance to coaching, please give importance to JEE preparation, college classes and all that. Try to, see if you can somehow adjust it, somehow, have a minimum attendance there, and try to give importance to JEE preparation. It's very important in the last few days, okay? Chalo. Now, this is one thing. Second thing is optimum speed. If the road is curved, obviously you're not always going to drive with maximum speed. You're not that idiot. I'm going to drive at the maximum speed. I'm going to push my car to the limits, and I'm going to use Shreyas Sir's formula, root rg tan theta plus mu upon 1 minus mu tan theta. And I'm going to be just on the verge of sliding, and I'll just turn my car. No, you're not going to be that idiot. You're going to be worried about your wear and tear of the tires. You want minimum friction. You want the tires to run for a longer time. So that speed is called as the optimum speed, and that optimum speed, alright, that optimum speed is root rg tan theta. Yes. So Ajasaran, in the flash series, I have derived, in fact I have shown how this formula comes. So please watch the flash series. Alright, it's there. Okay. So you can just watch it over there. Okay. Yes, that's how it is. Thank you, Krishna Yadav, so much. Jaideep, I have completed transistor in 0 to hero series of, communication systems and also semiconductors. So please watch the playlist. Those of you who are very new to this channel, let me tell you guys, there is a beautiful playlist out here on JEE Enthuse. So if you just go on YouTube and click on JEE Enthuse, well, you can go to playlist. You can also go to past videos. You can see all the past videos over here, but most likely you will be going to the playlist. And when you go to the playlist, you will see a physics playlist being created out here. All right, so you can just click the physics playlist. You have all the chapters arranged of the flash series out here. So you can see all the flash series arranged over here. Then you also have special series like important tips and strategy sessions, like for formulas, 11th formulas, 12th formulas, most expected questions, how to guess, MCQs, etc. All these things are there. And then on the top, all right, on the top over here, where did it go? Oops, 1 second. Over here, yeah. Over here, you will also see the 0 to Hero series. Yes, you will also see the 0 to Hero series. 1 second. Okay, yes, here, 0 to Hero playlist, JEE Physics. So you can see all the chapters are there over here. All the chapters, center of mass, communication, rotation, semiconductors, logic gates, transistors, all the things are there over here. So you can definitely go ahead and watch the same. All right. Okay. Swami Reddy Vishnu, all the important topics also is there in the playlist. And Akash, the session started at 7 o'clock because morning time is a good time. And it's a proven fact that if you study in the morning, then your memory improves and you have to work hard. All those people, all your friends who show off by waking up late. Hey, you wake up 6 o'clock. Yeah, I wake up at 10 o'clock, man. Yeah, I wake up at 11 o'clock. Oh my God, you are such a nerd. You wake up at 7 o'clock. Just ignore them because they are losing on their memory power. They are losing out on a lot of important time. All those people who tell me, sir, I'm not able to manage this time. I don't know how to prepare for boards. I don't know how to prepare for this. Guys, you are waking up late. Trust me, when you stay up late, it does not help. All right, you might think, no, instead of waking up early, I'll stay up late. What's the harm? Your brain is not active in the night, and it also increases the risk of heart diseases. A recent study said that it increases the risk of heart diseases, it increases the risk of strokes and other diseases when you grow up. So if you want a good health, if you want a good mental health, it's good to wake up early in the morning. Yes, Rock, it is important for JEE Advanced especially. Yes. Oh, is it? Oh my God. Let's do something then, Yalini. All right. Yeah, definitely we should do something. Yes, Aju, it comes in JEE. Yes, all of this comes in JEE. So this is a JEE channel. Whatever we do over here, obviously will be there in JEE, but it also helps in NEET preparation, KVPY preparation, and it lays the foundation for Olympiads, and it also helps you in boards. So mainly we are focused in JEE, and it indirectly helps you for NEET preparation as well, and other things. All right, very good. So Miss Devil, like I have mentioned before, that Wasim sir is not feeling well. He's suffering from corona, and that's why he is called it off, and he has been admitted to the hospital a few days back. So very soon he'll be also out of it, and we are all praying for this. Yes. Now remember, the Vedantu online talent examination is going to happen many times, and if you have missed the previous 2 dates, please attempt the V.O.T.E examination on 11th of April and 18th of April, where you can win a lot of scholarships and a lot of prizes from a pool of 500 crore rupees. You'll be getting a lot of scholarships, and also a chance to become Vedantu CEO or a trip to NASA, and lots of assured prizes like smartwatches, tablets, power banks, telescopes, Alexas, PS5, Xbox, and all that. So very simple, very easy to register for V.O.T.E. Just go to the link which is there in the description box, enter your name, get your voter ID, and even a kid below 18 years of age can vote. Select your dates appropriately and just use the Vedantu app to write the V.O.T.E examination. So it's all going to be objective format. So if you are 11th standard student, then it is for 90 minutes, and if you are 12th standard student, it is for 180 minutes. It has negative marks, and it's mainly multiple choice kind of questions. So let's start with our questions for today. Let's start with the questions for today. Okay, very good, Ashok. I am pretty sure the experience for live classes is very different than just watching the recordings. So that's what I would say for all the students watching this recording. Always try and watch the lectures live. The fun is different. And in fact, I posted a meme recently. Some people try and watch the recordings at 2x speed, and then because they do not understand that at 2x speed, then they again watch the replay 2 times. So effectively 2x speed watched 2 times is like watching the lecture normally. So better watch the lecture live. All right. So Srinath will be doing something for BitSat as well. Don't worry about it as the exam approaches. But as such, the preparation for JEE Mains and BitSat is the same. It's not different. So don't get fooled. A lot of people do this. Oh, I'm going to train you for BitSat separately. They don't do anything special. It's just JEE Mains training only. Understand that. But at the end of the day, just when the BitSat approaches, we just have to solve the BitSat related questions. That's all. All right. Very good. Let's see how many of you are going to get this. Okay, very good. Some of you have got it. Yes, the correct answer is actually B, guys. See, which of the following is false? Not true. Which of the following is false? So, for a particle moving in a circle, acceleration is towards the center. Yes. For uniform circular motion, acceleration is always towards the center. Correct. Acceleration is tangent to the circle. Obviously wrong. Come on, tangential acceleration is in fact 0. Velocity is tangent to the circle. Yes, as the particle goes in a circular path, the velocity is always along the tangent drawn to the circle. Correct. Velocity and acceleration are perpendicular. Yes, acceleration is towards the center, velocity is along the tangent. So obviously acceleration and velocity are always going to be perpendicular. Very good. Rock Satvik, like I said, the Advanced 2021 series is starting this Saturday. Remember, in physics, it's starting this Saturday. So we are starting Killer 5 series. In case you missed the introduction part today, please watch it. I've explained it, what the Killer 5 series is, and you know the entire schedule has been also mentioned in the video. All right, let's see how many of you are going to get this question. What is the angular velocity of the wheel if the diameter is 6 meters and a point on the rim has 18.84 meters per second? Come on, minions, let's see how many of you are going to get this. 18.84 meters per second. What is the angular velocity of the rim? Come on, come on, come on, come on, come on, come on. Krishna, there is nothing like weightage for any chapter in JEE. All those people who tell you the weightage of any chapter, they are all lying. They are just making those videos for views. So please don't get fooled by those kind of channels who tell you the weightage of every chapter for JEE or NEET. So understand, there is nothing like weightage for JEE or NEET. All chapters are important. You can just guess which chapters, how many questions come based on the past experience. But like I said, it's just a guess. You never know how many questions might actually come or not come. So JEE never fails to surprise us actually. Well, I'll tell you how to solve this. Angular velocity is velocity by r. Velocity, how much is it? 18.84 divided by r. R is, be careful, this is the diameter. So this is 6 meters. So this should be 3. This should be 3. Be careful. So this will be 6.28 radians per second. Now do not forget, the answers over here are in rounds per second. Now 6.28 is nothing but 2 pi radians per second, and 2 pi radians is 1 revolution or 1 round. So hence it is 1 round per second. Keep this in mind. So that's why the answer is actually D and not A. Lot of you got it wrong. Yes. Okay, Srinath, the thing is, bacha, see, every teacher has limited time. So a same teacher cannot teach in all the things. I know you all love us and you want us to be in crash course, pro subscription, 11th standard, 12th standard, topper batch, this batch, every batch, YouTube, webinar, what else? I mean, we cannot be there everywhere. So first of all the teachers in Vedantu are really awesome. So you don't have to worry about it. So some teachers will be on YouTube, some teachers will be in the regular batch, some teachers might be in the 12th standard batch, some teachers might be in the crash course. So we all do a mixture of things. Like I'm teaching the 12th standard topper batch, and over here Shimon sir will be teaching somewhere else and on YouTube. So you know, that's how things work. So understand, because time is a limited resource out here. All right. Good morning, Techolic. Yes. Capture the last part once. Okay, Yalini, the thing is 6.28 radians. 6.28 is how much? 2 times of pi. And 2 pi radian, how much is 2 pi radian? 1 revolution, right? So that's why it is 1 RPS, round per second. I hope now it is clear. Okay, chalo. Let's get going to the next question. Yeah, a lot of you got the previous one wrong, but it's okay. Let's see how many of you get this one correct now. There are 3 statements Some of them are correct, some of them are wrong. Which of the following statements are correct? Or all three are correct? Come on. I hope Yalini, you understood that statement now. Okay, cool. Let's see how many of you are going to get this. Read it carefully. I'm not going to read it for you. All right, choose the correct statements. The first one talks about net acceleration is always along the radius of the circle. Is always along the radius of the circle. All right, the velocity vector of the particle is always along the tangent of the path of the particle at that point, and the acceleration vector of a particle in uniform circular motion is averaged over one cycle is null vector. Come on, let's see how many of you do this. Definitely Surya, even I was a state board student and I cracked JEE, right? Who told you that? First of all, who, tell me the name of that person, or who gave you that idea that a state board student cannot crack JEE? Who was that person? Who told you this? Somebody has just fooled you. Please do not listen to that person ever again. Okay? No problem, Srinath. Watch the remaining part later on. Okay, come on. Well, I'll tell you what. No, it's not D, it's actually B. The velocity vector of a particle at a point is always along the tangent to the path of the particle at that point. See carefully and choose the correct option. See, if there is a path, if this is the path, all right, the velocity vector, all right, the velocity is always along the tangent. The velocity is always along the tangent. Hence, this option 2 is correct. Option 2 is correct. Now, the acceleration of a particle in uniform circular motion is averaged over one cycle is 0. Now, see guys, if you take uniform circular motion, all right, the acceleration here is this way, acceleration here is this way, acceleration here is this way, acceleration over here is this way in uniform circular motion. It's always perpendicular. What's the average acceleration? What's the average acceleration? It's there everywhere. What's the average acceleration? Obviously, it is 0. I hope you can see that. Average acceleration will be 0 because it's acting every possible way, so it becomes 0. So hence, option 3 is also correct. The net acceleration of a particle in the circular motion is always along the radius of the circle towards the center. Guys, read it. The net acceleration of a particle in circular motion is always along the radius. They have not mentioned the word uniform circular motion. It's just circular motion. So if it is just circular motion, then is the acceleration always going to be towards the center? No, it may be, it may not be. Hence, option number 1 is wrong. That's why only 2 and 3. I hope this is clear. Okay, I hope now everybody has understood this. So for a regular circular motion, there will be tangential, there will be centripetal, and the net acceleration will be here. This will be the net acceleration, which is not towards the center. Keep this in mind. Okay, let's get moving to the next question coming up on your screen. Okay, this is Zero to Hero series for all the 2021, for all the 2022 aspirants out here. Welcome Ganesh. Good morning Sujit. Yes, very good Shreyas, very good Minion Aarti. Excellent. Okay, so make sure that you attend these sessions, and if you still find difficulty and you want in-depth explanation, please watch the Flash series playlist again there on this channel. This Zero to Hero series is going to cover all the topics for 11th and 12th. So if you're a 11th standard student, watch all the 11th standard topics, and if you're a 12th or a dropper student, watch every topic before your April examination. Okay, what is the angular acceleration after 2 seconds? Good morning, Baby Luffy world. Okay, is it Kirito with a new name, Baby Luffy? Wow, Kirito, is that your new name, Baby Luffy? We had Monkey before this. Ankit, that's a good addiction, but I would be happy if your addiction is towards reading than just buying the books. Alright, Minion Aarti says C, Amireddy Vaishnu says C, Papi Reddy says 16, Sujit says C. Differentiate twice. Very good. Excellent, guys. So angular velocity is d theta by dt. So when you differentiate this, you will get 3t square plus 4t plus 1 plus 0. That's what you're going to get. Now when you differentiate this d omega by dt, you will get angular acceleration, that will be 60 plus 4 plus 0. Now angular acceleration at 2 seconds will be 6 into 2 plus 4, 12, 2 6 are 12, 12 plus 4 is 16. Hence the answer is 16 radians per second square. Correct, the answer is 16 guys, as simple as that. Very good, very good. Okay, oh my god, you're not Kirito. Okay, so looks like Luffy is the word guys, so Luffy is the word. So I'm not sure what Luffy means. Okay, I hope Pooja, now you understood your mistake. It's not D, it's C. Alright, okay. Yes, Ayush, it's 16. Very good. Let's get moving to the next question. A coin. How many of you have done this, guys, at your home? Take a sharpener or a rubber and place it on the blade of your fan. And then switch on the fan and then you see it flies off. And then you put the fan at different speeds and then check out, oh, at 1 it does not fly. Oh, at 2 it flies. Oh, at 3, oh, it flies off very beautifully. And then you place that rubber or that sharpener on the blade of the fan at different places and then have fun and then see how it flies off. How many of you have done that? Okay, come on minions, let's see how many of you can solve this also. So look at this question. So you have kept a coin on the table at a distance of 9 centimeter. If the angular speed is tripled and it just slips, what is the distance from the center? Come on, it's fun. Shreyas Capri also has done it. Oh, it's an anime character. Okay, interesting. Okay, let's see how many of you get this. Guys, it's just based on centrifugal force formula. Come on. Grade 4 memories. My God. I used to do it when I was in grade 9 also and grade 10 also. So maybe I had fun for a longer time. Okay, chalo. Let's do this. And what you need to do is, see, if the coin is kept here, the centrifugal force will be balanced by the frictional force. Alright? The centrifugal force will be balanced by the frictional force. When it is on the verge of slipping, this friction will become the max frictional force. So guys, all you need to do is compare the centrifugal force, because this Fs max will remain same because it is mu into n. Remember, mu into n is the value of Fs max, and that will be same no matter where you keep the coin. Coefficient is same. Normal force is going to be mg, so it is always going to be mu mg, so that's not going to change. So hence I can say the centrifugal force in the first case is the centrifugal force in the second case. Did you understand the logic? Because it's going to be equal to the frictional force every time. Now, very good Puneri Paltan, glad you are here. I'm used to that using pillow cover. Oh my God, pillow covers. Okay, pretty sure Dinesh, you got a lot of scoldings from your parents when you were a kid. Okay, Shreyas Capri got a lot of scoldings from their teachers. Looks like it. Okay, so centrifugal force in the first case is m omega square into r. R is 9 centimeters. Second case, it is m omega is 3 omega square into r. Now m goes, omega square goes. So 9 is equal to 9 into r. Therefore, r is equal to 1 centimeter, because this was in centimeters. So this r is also in centimeters. So hence the answer is D, which is 1 centimeter. Very good, very good. What is my age? Oh, by the way, I answered that in Coffee with Shreyas session. So please watch Coffee with Shreyas session. There I have answered what is my age. That's a very interesting answer, and it is not what you think it is. Okay. A circular racetrack. All right. 300 meters is banked at an angle of 15 degrees. If the coefficient of friction is 0.2, then what is the maximum permissible speed? Now I'll just tell you how to solve this problem, because the calculations could be tedious. So there is a banked track. Radius is given, angle of banking is given, tan 15 is also given. There is a standard formula which I just told you about, and that is maximum speed. Remember, the maximum speed is root of rg mu plus tan theta upon 1 minus mu tan of theta. Just use this formula. So what is the value of r? R is 300 meters, g is 10, and this will be 1. Oops, sorry. What is mu? Mu is 0.2. So 0.2 plus tan of 15, which is 0.27. divided by 1 minus 0.2 multiplied by 0.27. That's it. Just do that and you will get the answer. Yes, I hope this is clear. I hope this is clear. So just solve this and I think you will get the answer close to 38 meters per second. Very close to 38 meters per second. So these kind of direct questions do come in JEE Mains, and if you have attempted February or the March attempt paper, you know this. Very simple questions come. And plus direct formula application questions have also come many times in all the attempts of February, March and even previous years. So guys, you should know the formulas by heart. You should know how to apply them. You should know what each one of them is. Nobody can stop you from getting those marks. Yeah, just be a little bit quick in the calculations, that's all. Alright, so Ankit, maybe nothing, you'll just gain knowledge and you'll get confidence, but that is very important, getting confidence and knowledge and you know that satisfaction, okay, I'm doing well, and getting to know what are your shortcomings and what are your weaknesses and strength. That is very important. So every time don't expect me to give something, okay? Alright, so here it is, next question. Surya, which part you did not get? This is a direct formula. If there is a banked road, alright, that's a direct formula. Please watch the start of my class. I started with theory. Maximum speed is root rg tan theta plus mu upon 1 minus mu tan theta. It's a direct formula. More than that speed, it will skid off. That's a direct formula. I hope that is fine, Surya. Okay, then just substitute the values and solve it. That's it, which I just did. I substituted the values. Just figure out the calculations. Okay, let's see how many of you are able to do this conical pendulum problem. The radius of the circle is 0.4 meters, the radius. The angle is 45 degrees. The length of the pendulum is L. Then what is the speed of the pendulum in its circular path? Take G as 10. Oh, okay, Surya, no problem. You can watch the replay later on. For now, just attend the live class. Maybe later on, you can watch whatever part you missed. It's okay. So I just told you that formula is always there. Okay, cool. Come on, minions. Let's see how many of you can do this. Very good, Ankit. Very good. No, baby. There is no mentee today. Oh my God. Okay. So I never called anybody baby, and becoming a teacher, I have to start calling people baby. That's weird, you know. I never called anybody baby, not even my wife. All right, so, okay, kind of cheesy out there. Okay, let's see. Some of you are saying C option. Okay, come on, minions. What about others? Shreyas Capri also says C. Definitely, Kunal, you can definitely get, even if you get 99 percentile, you can definitely get a lot of good marks and ranks in JEE Advanced. Don't worry about it. There are a lot of examples over there. Yes. Definitely, Kunal. Just have confidence. Okay, baby Luffy baby, or should I call you Babu? Like a lot of couples do that, Babu. Okay, I don't call Babu. Okay, neither baby. Okay, so anyways, okay, I'll call you Luffy. Luffy is better. Yes, Abhi Bhabi. Oh my God, what is this? Abhi Bhabi. Okay, what kind of names are these? Abhi ke liye Bhabi. What is this? Okay, I don't know. Now, how to solve this question? Very simple. First of all, draw the free body diagram. So there is tension over here, and then you have the weight, which is mg. All right. And then you have your acceleration towards the center like this. This is the acceleration. Okay, this is not a force, this is just the acceleration which I have shown, and obviously this is theta over here. Now okay, Abhi, I hope you do not mind about it. Good morning, Naman Meda. Okay, so what you need to do is tension's sine theta. What is the sine theta of tension doing? Accelerating it towards the center. So it is m into AC. Therefore, T sine theta is m v square by r. That's one equation. Second equation, tension's cos theta. In the y direction, tension's cos theta is being balanced by mg. That's why there is no motion happening in the vertical direction. This is in the vertical direction, keep this in mind. So therefore T cos theta is mg. Now what you need to do is divide both of them and let's see what do you get. So when you divide both of them, what do you get? Sin theta by cos theta. Well, that's tan theta, dudes. I hope you guys got it. It's tan theta. Very good. And thank you, Abhi Bhabi. So all the current bhabis are a fan of my lecture. Thank you, all the bhabis of the current generation. All right. So those of you do not know what abhi means now in Hindi. All right. So here we divide both of them. So m and m gets cancelled. So we have v square over here and r below, and g also is below. So therefore v square is r g tan theta. Now just substitute the values. So v square is equal to r is 0.4, g is 10, tan of 45 is 1. So 0.4 into 10 is 4. So v is 2, and that is why the answer is D. Okay, morning Sri Sai Ram Studies. Thank you, welcome. Morning branded Kamina Kushuk. My god, guys, I had heard of Nike, I had heard of Adidas. Which kind of brand is this? Kamina Kushuk. Interesting. Very good. Okay. Nice brands. Very good. Future brands. Very good. Okay. Let's get going to the next one coming up on your screen. No problem, Abhi Bhabi. No problem. Happens. Even if you're wrong, we still love you. We still care for you. We are come here to learn. Even if you guys make a lot of mistakes, it's okay. I do not differentiate. I'm not like your usual teachers. Good morning, Yagnesh Sarvia. Welcome. Got it? Very good. Yeah, I'm loving the names in the chat too. Okay, so the angular frequency of a fan increases from 60 to 120 RPM, rounds per minute, in pi seconds. A dust particle is present on the blades at a distance of 10 centimeters from the axis of rotation. The net acceleration of the dust particle after pi seconds is how much? If pi square is 10. Come on, minions. Let's see how many of you can do this. Hello, Harsha Wendy. Welcome. Good morning. Hello, Yagnesh. Welcome. Okay. Hello, Ajju. Thank you for all the stars and the rows. Whether can I watch your full series or this series? Venkata, it depends whether you are a 2021 student or 2022 student. If you are a 2021 student, then watch Zero to Hero, and wherever required, watch the Flash series. But if you are going to give the exam next year, then watch the Flash series as well as this series. Okay. Thank you, branded Kushuk. I like your brand. It's a very Kamina brand. And then you also have a photo of, is it Sushant Singh Rajput by any chance? I cannot see it very clearly. All right, I'm a great fan of Sushant Singh Rajput, by the way. Yes. Okay. Come on. Yes, these kind of questions are definitely asked. Sir, I got 99.5 percentile. Yes, you are definitely, Purnima, eligible for JEE Advanced. So let's see how to solve this question. I have given you quite some time all this while. Okay. So what you need to do is find both kinds of acceleration. One is tangential, one is centripetal. So how do you find tangential? Tangential acceleration is final omega minus initial omega divided by, the time, divided by the time interval. Now, final is 120. 120 rounds per minute. 120 rounds per minute is 120 by 60 rounds per second, which is 2 rounds per second, which is 2 multiplied by 2 pi radian per second. I hope this is clear. So it is 4 pi radian per second. So 4 pi radian per second minus 60 rpm, that will be just 2 pi radians per second upon the time. Well, the time is pi seconds. So it is pi. So 4 pi minus 2 pi, 2 pi. 2 pi by pi, 2. So the answer is 2 radians per second square. That's the angular, this was angular acceleration. Angular acceleration. Now, if this is clear, we will find the tangential acceleration, which is alpha into r. What is alpha? Alpha is 2. We just figured it out. What is R? Where is R? Where is R? Where is R? Where is R? 10 centimeters. So 0.1 meter. So that is 0.2 meters per second square. That's tangential acceleration. Now let's figure out centripetal acceleration, which is omega square r. Now what is omega? Omega is 4 pi. Remember, the final angular speed is 4 pi. So it is 4 pi whole square into r, which is 0.1. Okay, so 4 square, well, that's 16. Pi square, well, that's 10. All right, into 0.1, which is going to make it 16 meters per second square. Great. Now, if this much is clear, let's find the total acceleration. The total acceleration will be centripetal square plus tangential square. Remember, both are perpendicular to each other, so vector addition, so it will be AC square plus AT square. So guys, it will be 16 square plus 0.2 square. Now this is a very small number in front of this big number, so it will be approximately 16 square, which is nothing but 16. So the answer is 16 meters per second square. Correct. I hope this is clear, guys. Is this understood, all the minions? Is it clear? Shall we go ahead? Shall we go ahead? Let me know in the chat box. Okay, so you have to find tangential by finding alpha. A lot of formulas. First find alpha, then AT. Also find AC, then take their vector addition and then do this approximation to get the answer. Beautiful question. Let's get going to the next question coming up on your screen. Hardly 2 more questions are remaining. Okay, I'm very good, Nega. Thank you very much. Okay, let's see how many of you can do this. There is a car which is moving on a circular track of 40 meters with a constant speed. There is a bob which is suspended from the roof. Imagine you are in a car or a bus, and the car or that bus is going in a circular track. So that bob is going to sway, it's going to swing away. What's that angle by which it will swing away because of the centrifugal force? Come on, this is an easy question, you should be able to get this. Vishwa, more 15 minutes. More 15 minutes or something like that, that's it. Okay, Vishwa? Yes. Nega, I just mentioned it some time back. I think you were missing at the starting part of the class. About Wasim sir, yeah? Okay, very good, Abhi. Sir, is there a trick to memorize formulas? Well, some formulas yes, some formulas no. The best thing to do for formulas is write it randomly many times during the day and then solve questions based directly on those formulas randomly, and then do this over extended periods of time. You will slowly start remembering the formulas. No problem, Vishnuta. I hope you can watch the remaining 3 questions or something which is remaining. Now, remember this. I have done these kind of questions where you have a trolley, all right, and let's say it is accelerating or something like that. Then the pendulum box makes an angle theta with the vertical. Okay, the pendulum bob makes an angle theta with the vertical, where tan theta is that acceleration divided by g. That acceleration divided by g is tan theta. Now, in this case, this acceleration is none other than v square by r. This is v square by r, guys. That's it. So, because it's accelerating towards the center, so that's why it's going to swing away from the center. So just do that. So it's v square by r g. And what is v? Velocity, 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 20. So 20 square by radius, 40. G is 10. 20 square is 400. 40 into 10 is also 400. So this will be 1. Now whose tan theta is 1? Obviously 45 degrees. Hence that's the answer. Very good, Sujit. Very good, Divya. Very good, Kirmai. Very good. Excelente. Excelente. Very good. So, yes, that's the answer. Okay. So, next question coming up on your screen. This is the third last question. A particle is moving in a vertical circle. This is very straightforward. A particle is moving in a vertical circle. So, guys, there are 2 points. One is the position where the angle is 30 degrees and another position where the angle is 60 degrees. So where do you think the tension is more, T1 or T2? Remember, T1 is when it is 30 degrees, T2 is when it is 60 degrees from the vertical. Where do you think the tension is more? Oh my God. So Vishwa, if you can prepare for your boards on your own, do that, because honestly for boards you don't need tuition classes. Honestly for boards you just need previous year question practice, and you should practice on your own, writing down those derivations, formulas, definitions, give reasons, back exercises and all that. So please, there is no need, don't waste your time in boards. Please prepare for JEE. Automatically you will prepare for boards, and you can prepare for boards at your home only. Okay, so that's why you will not be able to manage the time. Yes, the correct answer, guys. Come on, a lot of you are saying B or C. Guys, the tension is more as you go below, not on the top. As you go below, the tension increases. Have you ever gone on a swing? Where do you think the tension is highest? Where do you think the tendency to break is highest? At the bottommost point. The tension increases as the speed increases. So as you go below, the tension increases, and hence the answer is T1 more than T2 at a smaller angle as you go below. I hope this is clear. Okay, let's see if you can do this question. It's very simple. There is a bob and it is given some velocity u. Now it is going in a circular path like this. It goes in a vertical circular path. Speed decreases. Now consider two instants. One, initially when it is given the speed u. Initially it's given the speed u. Then after some time it makes an angle 90 degrees with the vertical. That time it has a new velocity v. Question is, what is the change in the velocity? Figure out what is the change in the velocity. Yes, April session will maybe easy. I do not know. Nobody can guess it, Avi. Come on, think about it. What is the change in velocity? Come on, minions, think about it. What will be the change in velocity? All right, come on. Yes, very good. Yes, Divya, you will feel lighter when you go up in a swing, and when you are at the bottommost point, you will feel heavy. That's why the tension is more. Okay, no problem. Even if you guys did not get it, I'll tell you how to solve it. See, at the bottommost point, the velocity is u. Okay, maybe you cannot see it that way. I'll just put it this way. The bottommost point, the velocity is u, and when it comes over here, the new velocity is v. First thing to do is figure out, what is this velocity v using energy conservation. So let's do that. So using energy conservation, what I will get is initial kinetic energy goes into the potential plus the final kinetic energy. So the initial kinetic energy which was there below goes in, some of it goes in kinetic energy and some of it goes in potential energy. I hope this is clear. Now, what is the initial kinetic energy? It's half mu square. What is the potential energy? Well, this height is nothing but h or r or l, whatever it is. Yeah, this is L. So it is mgl plus half mv square. Now m goes, multiply both sides with 2. So it will become u square is equal to 2gl plus v square. Therefore, v square is u square minus 2gl. But that's not the final answer. Be careful. The question says change in velocity. Now remember, change in velocity is final velocity minus initial velocity is vector subtraction. You have to find a vector subtraction, not just the plain subtraction. So be careful. So what is the final velocity? It's here. Final velocity is v upwards. What is the initial velocity? Initial velocity is this way. So the negative of the initial velocity will be that way. Initial velocity is this way because you are subtracting. The negative of that will be this way. So this is minus u. Correct? And their sum is basically the change in velocity, which is what you want. Now think about it. What will be delta v? delta V will be V square plus U square. Or even if you take minus U square, it's the same thing, because when you square it, that minus sign goes off. So just do that, and what are you going to get? V square, that's U square minus 2GL plus U square over here. So U square plus U square is 2U square. So 2 will come out common and the answer will be D. Understood? Yes. A lot of you thought you had to find V. So that's why read the question carefully. You had to find change in the velocity, not the final velocity. I hope this is clear. That's why many people write this as the answer A, but that is wrong. Or some people just write B. I don't know why, but it is not A, mother. Okay, it is not A. The answer is this one. A is different. B is this one. This is nothing but root of 2U square minus 2GL. Take that 2 common. Take that 2 common. I hope, Madhav, you saw your mistake. All right. Okay, come on. Let's do this next question coming up on your screen. That was option D. Very good, Luffy. Excellent. Last question. Let's see how many of you can do this. Last question. Let's see how many of you minions can do this. Thank you, Shreyas. You guys understood. Very good. Very good. Clear. Okay. So you have kept a block on the top of a smooth spherical surface. You give it a small push. It falls and it loses contact somewhere else. It loses contact. The question is, at what angle with the horizontal does it lose contact? Come on, let's see how many of you know this, how to solve. Come on, minions. So this is it. This is theta. All right, it was at rest. It gains some speed over here. And remember, it's clearly mentioned that the normal force becomes 0 over here. Question is, what is that angle theta? Come on, minions. Okay. Very good, Gayatri. Very good, Yalni. Good morning, JEE Enthuse South Indian Clan Club. A little bit late in waking up, I guess. Yes, Vishnuta, because the question papers were very easy, so that's why many of them scored very well. So only if your scores were high, you would have scored well. Okay, come on, let's do this. So Branded Kaushik, the next class of mine will be tonight at 9 o'clock. I'll be starting the first chapter, the first lecture of our Pathfinder series tonight at 9 o'clock. So if you are a 11th to 12th moving student and you want to watch all the lectures on YouTube of all the chapters of 12th standard, guys, today we are starting Pathfinder series and my lectures will be at 9 o'clock. Okay. Yes, Vishnuta, the competition is tough. I'll tell you how to do this. Okay, a lot of you are saying C. I'll tell you how to do this. First of all, draw the free body diagram of that body. Okay, so this is the free body diagram. The normal force is 0. The mg is there, so I'm going to split up mg into 2 components because it was mentioned that, you know, this angle is theta. So naturally this angle is also theta and this angle is also theta. Remember this trick I have told you before. So just divide it into 8 parts and every alternate will be theta. Every alternate angle will be theta because the angle theta is with the horizontal. So if this is theta, every other angle will be theta over here. And then if mg is down, this will be mg cos theta and this will be mg sine theta. This will be mg sine theta. The last thing, the acceleration will be towards the center and there will be tangential acceleration like this. Okay, these are the forces, these are the accelerations. So along this line, okay, along this line, there is only one force and that is mg. So mg sine theta, there is no normal at that point, is mass into acceleration. Acceleration is v square by r. So mm gets cancelled. So in this mg sine theta, mm gets cancelled. So v square will be rg sine theta. Okay, keep this in mind. This is the velocity which I get. But I don't want the velocity. I can get rid of it using energy conservation. Use energy conservation. So from here to here, think what happened. The potential energy initially got converted into the kinetic energy. So potential got converted into kinetic. So just see how much is the loss of height. How much is the loss of height from this point to this point? I feel it is r minus r. What is this? If this is theta, this is r sine theta. This height difference is r minus r sine theta, which is r into 1 minus sine theta. I hope you can see that. I hope you can see that. If this is r, this is also r. Now this much over here, look at this. This much will be r sine theta. So how much is this much? R minus r sine theta. So that's what this is. Now, what is the potential energy? mgh. H is r into 1 minus sine theta is final kinetic energy, which is half m v square. Take v square from here. So it will be r g sine theta. Okay. Now mgr gets cancelled. So take that 2 on the other side. So 2 into 1 minus sine theta will be just sine theta. Okay. Now you can write this as 2 is equal to sine theta from here, and take that minus 2 sine theta over there. So it will become plus 2 sine theta. So therefore 2 will be equal to 3 sine theta. Therefore sine theta will be 2 by 3. That is the answer. Sine theta is 2 by 3. Look at that. That is option A. Yes, Suyash, we are going to have these morning classes because that is good for health mentally and physically. And all those students who want to clear JEE should attend the morning classes. If your aim is not IIT, if your aim is not NEET, if your aim is not a good engineering college, then please wake up. Very simple trick, guys, how not to get a good college. Wake up late, be lazy, and sleep late and study in the night. That's the simple trick to get a not so good college. As simple as that. All right, so that's the answer, guys, for today's last question. And if you want to join the crash course, which has just started yesterday with lots of live classes, all the 11th and 12th topics revision in live classes with problem solving, assignments, in the class doubt, outside the class doubt, and you can watch the replays of the lectures any number of times you want, along with a special doubt app to solve all the doubts of no matter which subject, which book, whatever conceptual clarity you need, free of cost. You can ask any doubts, and 15 full syllabus and 5 part test series with discussions and analysis. Then please consider joining the crash course. The details, the link for the same is mentioned in the description box below. And when you use the coupon code SHCC, you get 4,000 rupees off, and the crash course is hardly for 6,000 bucks, which I feel is a very, very good deal. So do consider joining the crash course because it has just started yesterday, that is 5th of April. And if you have enjoyed today's session, if you have enjoyed and if you have loved today's session, so guys, please do not forget to smash the like button, share this channel, share this playlist with your friends, your loved ones, so that they also get the benefit of this, because this is an English channel. Not many people out there teach in English. And do not forget, if you're a new user, do not forget to hit the subscribe button out there. All right. So see you guys tonight at 9 o'clock in the first class of 12th standard in the Pathfinder series on electrostatics. Bye bye. Take care. Yes, Sanjay, we are starting with JEE 2022 series tonight, 9 o'clock. So be there, Pathfinder series. Okay, Sanjay, it's there.